Hi everyone and welcome. I'm just getting ready to cut out the new LaserShoe body. It's made of two parts, the first being the body and the second being the base. Now the base is cut from 12mm MDF and the body is cut from 18mm. Now I've chosen 12 for the base because it's a little bit thinner and lighter. I'm just keeping the weight down. I believe the less I've got hanging off the router, the better. So I'm just concentrating at the moment on the body, and that's going to be made from 18mm MDF, and it's cut entirely using a single 3mm cutter. Now before you start making yours, you need to make sure of a couple of things. The drawing is set for my machine, but no two homemade machines are the same. So there's two critical measurements that need to be taken into account. The first measurement is the diameter of the router body. Mine's 3.5 inches in diameter, and that's going to be determine the size hole that you need to have in the top of the shoe for clamping. The second one is the distance from the back of the router to the back of the plate here. The LaserShoe needs to lock in place, so I'm locking it in by locating it on here and touching the back plate here. If you don't have it like that, then it can swivel side to side, and unless it's put back in exactly the same location each time, the registration marks that we'll put on the shoe later will no longer be accurate. So it is critical that some method be installed on the shoe to assure its alignment is the same each time it's put on. Right, now our bits are cut, and we should end up with 4 pieces. We have 2 that look almost the same, but one has a wee notch out of it here. This piece here, which is obviously the top bit, and a small ring of MDF with a hole in the middle. Now what I've done is I've got a drill and just drilled this out a bit bigger. I went to 6mm. And it will sit just in this recess here. And it should just press in like so, and you'll end up with that there. So the laser is going to sit in here, and the light will actually shine through the small hole here. Now it's critical, having made these pieces, that we check them for size before we glue them together, because if just one piece is wrong, then the whole thing becomes a throwaway once it's glued. So this piece here, the hole in here is slightly bigger than the router. I left a little bit of leeway in there. So you should find both these pieces here are loose on the router, but this one here should be a pretty good fit. This one should just slide on like that, and this here will ultimately clamp together here and hold it tight in place. So that should be a nice, neat fit, and there's no slop in there. I'm now going to glue the part of this together, and then I'll move on to cutting the bottom piece while the glue dries. I'm going to start by gluing the small piece here in, the little circle. Just going to apply a little bit of glue, and basically just press it into place. Just make sure it goes in and sits nice and flush there. got a little bit of glue squeeze out there, so I'll just grab a rag and just wipe the excess off like so. Okay, that's looking nice and flush. If it won't go in properly, then just simply tamping it in with a hammer, or likewise put a clamp on there and pull it tight. Right, now the next piece we're going to add is this one here. It's the piece that has this little notch out of it. This is going to be for the centre of the hole cutter that we'll be using to cut the hole for the hose coming in from the side. You'll find it's actually sitting here in between these two screws, so we can be pretty confident that when we drill our hole through here, we won't be hitting those screws. The critical thing about this here is you need to decide which side of the shoe you want the hose to come out of. Now in my case, I want it to come out on this side here, which means the notch needs to be on this side here. So it's going to go together this way here. It would be wise at this point in time to take a pencil and just put a wee mark like so, so that we get it right. Those two faces will go together. Okay. So what I'm going to do is, I've got all these screw holes here, is I'm going to put screws into them. These are 25mm. I'll just put a handful in to start with. And the purpose of these holes is to aid the gluing process. If you try clamping it, the whole thing will just slide off to one side. So by having these holes, everything will locate properly, and you're not going to be chasing the MDF about. So our X's are there. Let's just put a bit of glue on it. Now another critical thing is, do not get any glue in this area here. This has to be able to squeeze here. So probably even back as far as here actually. Just avoid putting glue. We won't even put a screw in here once it's finished. And that's just going to allow for the clamping. So I'll just go from about here. Just going to put a bit of glue on. Get away from there. See how we look there. Just put a little bit more in where I've missed. Right, and as you can see now, the whole thing's just hydroplaning around the place. Trying to do these with clamps would not be very nice at all. Right, so we're getting good glue squeeze out there. I can see glue's come out in as far as around here, but there will be none in this area here, so it'll be able to still be able to clamp. So we'll just get our cloth here and just clean it up. And as one last test, we'll just make sure it still fits. Just got the bowl away. And it still fits on the router there. So that's good. And you'll see here, there's once it's clamped up here, there'll be no movement, or very little movement side to side on it. Okay, well, while that's drying, you'll notice as well I didn't put a screw in here because this particular hole ends up just on the outside there. So while that's drying, I'm going to go and cut the bottom. Bottom base piece. It's got basically two holes here. Now you'll find this hole here is smaller than that one there. It just stops the router pushing all the way through, though you'll still need to have it a bit higher than that because you don't want the collet nut coming through the base here. It'll get in the way and hit whatever it is you're trying to machine. Now, what I've done now is I've just quickly laid this piece here on top, and I got a pencil before and just marked roughly where the end of this here is. Because what I'm going to do is I'm going to go around here with a chamfer bit on my router table, and I'm going to chamfer the entire bottom here, but I don't want to chamfer this length here because it'll just look silly when this piece is attached to it, so I'm going to basically stop when I get to there. Right, now I've removed the screws from here, the bit we glued up earlier, and I'm now going to glue the next piece of this in place. Also, when you guys weren't looking, I quickly ran a round over a bit around the outside edge here, and just in here as well. Again, just a slight round over, just to make get rid of those sharp edges. This time I'm using much longer screws. These ones will go right through the two layers and into the third one there. Right, yeah, that's given me a bit of glue squeeze out there, so I just need to tidy that up and we'll leave that to dry. Now it's time to drill a hole in the side of here, and that's where this notch I have here comes in. That will put my hole dead center of these two screws so I won't hit them. And I want to drill a hole so that the edge of this here just skims the MDF here. So what I can do is I can drop the center of the drill into my notch, and it will align it that way. And I'm just going to use a piece of MDF here. I'm just going to sit it up there like that and swing the box around to it just rubs up against the side of that. And that should now align it spot on so that I will be drilling my hole just on the edge of the MDF here. This is a 41mm hole saw. I'm not sure what that comes down to in inches. So here we are. It's 1 5/8. That suits the pipe that I've got. The pipe I've got is 40mm internal diameter and is 44mm external. These always drill a slightly bigger hole, so I'll assume 42. And yeah, it's going to be very, very close. That's why I'm just going to nip the edge here. Well, that's come out just as I'd hoped. It just hit the edge here, and another advantage of getting this edge here is that the sawdust will come out the side. You don't have the thing clogging on you. You don't have half the hassles you have when trying to just drill straight through a material like this. Now I've gone ahead and painted the shoe, and as you can see here, I've just painted up. I put black on the inside here and black on the bottom so that there's no reflections of the laser. And basically I've just painted this with just some house paint I had laying about. It's the same colour as all the machinery I've built in the workshop, so it's as good a colour as any. Now I've also added a couple of holes. I found once I put this together that I needed to put some holes for cable ties. So I've updated the plans to put a little slot in just in here and some holes. The holes only go through the first two pieces of custom wood, and you need to drill the holes to suit the cable ties. Just drill them all the way through. They're going to be for cable tying the pipe to the side here to keep it in check. Okay, now the other thing I've done is I've drilled a hole. I just grabbed my battery drill, put a 3/16 drill bit in it, and just drilled through there and straight through into the centre of there. Just did it by hand, nothing special. I then got a piece of just a piece of steel. This is 6mm thick steel. I pushed it into the slot there. Then got my drill bit again and just drilled through until I made a mark on the steel here, which will show me where to drill the hole. I then drilled a hole to suit the tap, a 3/16 tap, and I've put a thread into my block there. Now my original plan was to use a nut in this point here, but what I found is it might be okay on the likes of Perspex or something harder, but MDF you need something big and solid. So hence just made my own nut there, and just a 3/16 bolt goes in there, and once it's lined up we'll just be able to pull the tension on this point here. Okay, next job is to screw these together. Now before I do that, I've got my piece of pipe here. This stuff's called Betaflex. It has a 40mm internal diameter here, and it's about 44mm on the outside. So I said originally this here hole in here ended up just a bit smaller than I wanted. So I just got a bit of sandpaper and gave it a bit of a sanding, and just sanded it out to the size I now require. So basically this here just pushes in here, and just pushes in a wee way. Just don't cover the small hole here, so I'll just bring it back a little bit there. Now you notice as well it's just pushing through a little bit prior to this point here, and that's where having that there go through is good, because it means when this is screwed down it's going to tighten up on the it's going to tighten up the pipe there when it pushes down into there. Okay, well now we're ready to screw the bottom on. Right, that's the last screw in on the bottom there, and now it's time to put the cable ties in. I put one in earlier. You can either put them in before they're screwed down, or you can actually put them in afterwards. So it should just push through like so, and just grab hold with a pair of pliers and pull it through like that. Right, so basically they're just going to hold my vacuum hose in place like so. It's better finding a pair of cutters and just cut the cable ties flush like so. Okay, well that'll take any strain off here. And next we need to look at mounting the laser here, and I'm also going to, just over here I'm going to put the box to turn it on and off with. Okay, well the next job I need to do is I need to mount the laser onto the shoe. Now this laser here is a blue laser. It's made by a company called CNCnutz.com in Turkey, Kale spelt K-A-L-E. So if you look up their website, www.kale.com, and I actually brought this one off eBay. They have a presence on eBay, and their lasers come in different types. Like I said, this is blue. They also sell an infrared that looks similar to this, both in 2-watt and 3-watt versions. And also, they also have some other smaller modules as well. I picked on blue, and because I wanted to be able to see the laser itself, the beam, whereas you can't see infrared. Right. So what I'm going to do first is it actually came with these mounting screws as well. They were supplied. And they got these 2 mounting holes, one here and one here. So I'm just going to take a square, and I'm going to transfer the center of the holes, with the pencil, just up close to the top of the box there. Now I've already made this bracket, but what we want to do is we want to have the bracket here flush with the bottom of the laser, and an easy way of doing that is just get a block of wood. So I've got the small piece of wood here and just sit it on like so, and then I can take my aluminium piece and just hang the thing over there. Now they're sitting flush, and I can transfer the mark here and here, the centre of my holes. Next, I can come across here, just pull it to the side, and I can now transfer this hole across to here, like so. It then becomes a simple matter of just joining those two lines up there. Just bring the transferred holes across and square the transfer holes down, like so. And that is where I'll drill my hole. At the top here, it's the same, but it's only sort of a half hole that's required here. And in actual fact, if I had a say a 60mm piece of angle aluminium, that's be alright, but I just found 50mm. I had a piece laying about, and it holds it well enough. There's no point going overboard on it. So the next job is to drill out the holes. As you can see, I've already done it on mine, and it should just screw together quite nicely. Okay, now we can look at mounting it onto the machine. Now when I made this laser shoe, I made this one specifically to go with this laser, and there were 3 torque head screws sitting through the bottom here, and I made this hole here. Those 3 screws just drop in there, and there's very little movement, probably about a millimetre or so of movement. Anywhere in that hole will be fine. The laser will go straight through because there's a small hole in the centre here. So it's just really a matter of putting it where you want to put it, and then a couple of screws through there's a couple of holes here in the aluminium. Now the last part we need to add to the laser shoe is this. It's the control box, turns it on and off. This is the one I've made for mine, and depending on what type of laser you get, you may not even require one. Some lasers you buy off the shelf already have bits of on-off switches and all the rest of it, even power supplies built into them. So long as basically it can mount on the shoe and shine a light through the hole, then that's basically all you need. The purpose of this box is simply to provide the power, and it also passes through the TTL signal that comes from your controller. So here we've got the incoming power coming in here, and the TTL signal is also in this cable here, and here is the the plug that will plug into the top of the laser here. Also in here is an on-off key, basically just for safety, so nobody can come along and just turn it on. If you keep the key with you, then that will stop them doing it. It also has a relay built into this, and a mercury switch, which you can just see down there, the little glass piece here. Basically what it means is this must be orientated vertical this way here. So basically if anyone takes the shoe off, powers it up, turns it on, flips it over, the laser will actually shut off. This relay here, when you turn the power switch on, basically nothing happens. The relay doesn't energize, the laser doesn't turn on. You then have to push this button here. When you push this button, the relay will turn on. It will latch on in that condition until it's either turned off or somebody flips the laser unit over. And that doesn't necessarily mean that the laser beam itself will turn on, but what it does mean is that if the laser beam is actually set from your controller to be turned on, simply flicking this key on will not actually turn the laser on. You still have to push this button, and likewise if the key's off, pushing this button will not turn the laser on. So just an added layer of safety there. Right, so mounting it's very easy. Now I'm not providing video instructions on how to build this. This is something I just can't video. I have drawn up some diagrams of how it all goes together on the Vero board here, using the components that I selected for my one. And basically this is something you either know how to make or you don't. If you don't know how to make it and you do need one, then it's the best idea would be to find somebody who knows how to solder together a simple, and it is a very simple circuit like this here, but like I said, there's a drawing that goes with this here that shows how it all goes together. Here's the drawing here that I did that shows basically the Vero board layout, the direction of the copper, the relay here, what tracks to cut, they're shown here, and where the connections are made. So having built this, basically it just remains a matter of just mounting it. Now if you do build one and put in the box there, you obviously, depending on which side of the machine you want to put, if you want to put it on this side of the machine, then obviously the switch would go there and the key would go there, but I've made it for this side of my machine, so ultimately it's going to go here. And it's just a simple matter of a couple of screws to hold it in place. I just drilled a couple of holes in the back of the box here. So just a couple of screws will mount this in place here. And then I just need I left my wires a little bit long there. I probably could have cut them a bit shorter. Now the particular box you use to mount this in is not critical. Likewise, you'll see the circuit on this one here ended up in the lid. That just happened to be the way this box is constructed. It could just as easily have been mounted against the back there. The ways of doing this basically are endless. It just depends on what materials you have available and how you choose to put it together. The circuit board likewise could have been a lot smaller. I made it long enough to fit on some mounting posts on the top here. But yes, it could have been made in a much smaller box than the one I've put it in. Just get the screw in, and there we have it. This just simply plugs in there. Now what I will say is, before plugging it in, there's a few tests that can be run, and I'll show you those. So the first thing I'm going to do is I'm going to just check the orientation of this plug, and I can see this is the positive, this is the ground, and this is the TTL signal. So I'm just using an old analog meter here. This one, if anybody's interested, I got for my 10th birthday some 36 years ago. And I still use it. So I've set it on the 50 volt scale because I've got 12 volt coming from the power supply to the laser. The laser's, this particular laser is 12 volts. And the first thing I'm going to do is I'm going to turn on the key. And as you can see, nothing happens on the meter, which is exactly what we expect. Next I'm going to push the button. And here we've got 12 volts coming up on the meter here. So that's exactly what we want this to do. When I turned off, 12 volt disappears. So that's a good start. What isn't a good start here is when I push the button, the red LED here didn't come on. Now that I know about, the LED in this particular switch is faulty, so I don't need to worry about that, and I have a replacement key switch that or push button switch that will be arriving shortly. When I built this, I didn't actually have to use a switch with a built-in LED. The LED is only to show me that it's on. I could have actually just put a little LED indication here, completely separate from the switch. It's sort of whatever sort of takes your fancy, really. So I will get that fixed, but that's not a deal breaker at this stage. Right, so again, when I turn the key off, it turns off. When I turn the key on, it doesn't come back on until I push the switch here. So that's great, that's exactly what I want to happen here. Right, well, the next test I'm going to do is on the TTL lead to see if I've got control. Now, I don't need to do this. My main concern is that I don't have any extraneous voltages on there. So what I'm going to do is I'm just going to start by, I'm going to just turn my meter down to 10 volts. And I'm going to go between the ground. I'm going to put the negative lead of my meter to the ground, which is the centre pin there, and the positive to the TTL lead. And I get no reading on my meter, so that's good. There's no extraneous voltages there, and that's with the LaserShoe power box powered up. Right, well, next I'm going to go from I'm going to put the positive lead onto the 12 volt side of the LaserShoe, and I'm going to put the negative on the TTL. Now, I would only do this if I'm running it as I am from the output pin of the G540. If I was running it from the parallel port, I would not do this. I would simply test it by plugging it into the laser and giving the commands from the thing. So just be warned, I'm only doing this because I know I can get away with it, because I'm using the output pin, one of the output pins of the G540. Okay, so what I'm reading here is 12 volts, so that means that the TTL lead here is now grounded, which I expect it to be. Now, a grounded TTL lead on my particular laser means that the laser would actually be turned off. So what I'm going to do now is from Mach 3, I'm going to issue it an order. In my case, it's going to be tell it to turn off, and there we go. The TTL lead has now actually gone down to 0 volts, which would mean there's no signal coming into the TTL lead from the G540, which means the laser would actually turn on. If I now give the command to turn the laser on it comes. So I know that that's actually working. But like I said, that particular test you don't need to do, and certainly do not do it unless you are running it as I am from one of the two outputs from a G540. Well, that concludes the building of the LaserShoe. In the next video, I'll be covering the building of the fan unit that we will be using to extract the fumes from the shoe here and send them outside, and also the alignment of the laser with the shoe so that we know where the beam is. Okay guys, well, we'll catch up with you on the next clip. Cheers!